All right, so in chapter 1, section 8, we have the combination and composition of functions. So like for number 2, we're just adding these two functions together. Um, if there's nothing to do, there is nothing to do, right? So x squared plus 7 plus the square root of 4 minus x. And so that's the answer. Nothing to do on that one except to add the two functions. We combine B, we're subtracting them. C, we're multiplying them. So for C, it's just, we don't have to expand it. There is nothing to expand, but we're just multiplying the two functions. So sometimes functions come together, like if you look at a profit equation, it's a combination of functions. It's revenue minus cost. If you're like rate equals, or rate times time equals distance, maybe you're calculating a distance and you have an equation for rate and an equation for time. So we'd have to multiply two different types of functions. When we're dividing functions, works the same. It's going to be this is your numerator, this is going to be your denominator. But then it asks for what is the domain of f over g. Well, now I have the square root of 4 minus x in the denominator. And so if we're looking at that, so let's look at that problem. So x squared plus 7, and we're going to divide all of that by square root of 4 minus x. Now, if you look at this graph, like, doesn't look like it goes everywhere. You know, is there something somewhere else that we're missing, or is it just to a certain value? It looks like it goes further off that way. Does it maybe have an asymptote right here where it's not values? Well, if the root 4 minus x is not allowed to be 0 or an imaginary number, we want real defined values, then that means x has to be, well, it can't be 4 because that would make it 0. So we know it has something to do with a 4, but is it the number is less than 4 or greater than 4? If I had 4 minus 100, I'd have a negative number. So I want to have negative values, so let's go to negative infinity to 4, not including 4 because I would have 0 in the denominator. So that is a way, what we have to look at when we're doing a combination of functions we're dividing is maybe our range is going to be a little off. Or a domain. Our domain on this one would be, it would be similar, but it would include 4. This one doesn't include 4 because it's in the denominator. Let's look at number 8. So this is a composition of functions. So I'm putting one function into another function. So if I wanted to look at this one, and I'm composing f of g, I am taking my f function, 1 over x, and I'm putting in for x. So I'm doing f of g of x, right? So whatever I have for g of x, I'm going to put in for my x value. So what we would have here is 1 over what my g of x is, x plus 6. Like that is what f composed with g is. Now g composed with f, so it would be g of f of x. So whatever I have for f of x, I'm going to put in for x in my g function. So this one's going to look a little different. It will have 1 over x, because that's what f of x is, plus 6. So instead of writing x, I wrote what f of x is, 1 over x plus 6. And then we can play with the domains of these functions. Like this one, the domain would not include negative 6. This one, the domain would not include 0. These compositions. One more to look at was number 13. And so this one is using the graph to evaluate some of these functions. So f plus g, I'm adding up these two functions evaluated at 0. Well, my f function evaluated at 0 is 4. My g function evaluated at 0 is 4. So 4 plus 4 is 8. If I'm dividing and I'm looking at 2, so f of 2 is 0 divided by g of 2, which is 2. So I would get 0 over 2, which is 0. So just using these values of the graph to evaluate a function.